Let's talk about the third measure of dispersion, which is variance. So the variance of a variable in a data set is given by the equations below. So we use sigma squared for the population variance and S squared as the sample variance. You should note that these formulas are exactly the same as the ones for standard deviation, except they don't have the square root. So there's no need to actually go through the whole process. Once we have the standard deviation, all we have to do is raise it to the second power. So if we go back and we compute the variance from this last problem we had, our S, our standard deviation, was 13.05. So the variance, which is S squared, we just take 13.05 and raise it to the second power. And when we do that, we get approximately 170.3. So the symbols for variance even tell you how to calculate it, because the symbols are the same as the symbols for standard deviation, except with an exponent of 2. One thing I should mention about standard deviation and variance is neither one is resistant. And that's because all the data values, every single one of them, is used in their calculation. And so that means if there are any outliers, then those would be part of the calculation, and so they would change the standard deviation and the variance. So now we need to talk about bias. Whenever a statistic consistently either underestimates or overestimates a parameter, it is said to be biased. So the sample standard deviation is a biased estimate of the population standard deviation. It never gets it quite right, in other words. Okay. Let's talk about using the calculator. That same function, oneVarstats, which remember we get to that by hitting the stat key, and then going over to the calc menu, and then picking number 1, which is oneVarstats. That gave us the mean and the median. It also gives us the sample standard deviation, which it labels SX, the population standard deviation, which it labels sigma x, the smallest data value, which the calculator calls min x, and the maximum data value, which it calls max x. So to find the variance, you can either use this set of keys. So you press the Vars key, then go over to the Vars menu, choose number 5 statistics. The whole process is right here. Or write down SX from the one var stats and type it into the calculator and then square it. So you have two options. So the calculator won't tell us the range or the variance, as I said, but it does give us the maximum and the minimum, and we can use that to find the range. So let's use the calculator to find the range, standard deviation, and variance of the sample data. So we're going to go put this stuff into our list, the data. So remember, we hit the stat key, and then we want to edit our list, so enter. Now we need to clear out what was in there before, so arrow up so that the L1 is highlighted, hit the clear key, and hit enter. And now it's all cleared out. So now enter your data values from this example. So we have 25, 37, 24, 40, 57, 59, 44, 34, and I'm going to check in reverse order. So I have 34, 44, 59, 57, 40, 24, 37, and 25. Good, no typos. So I use second and mode to get out of my list. And now I'm going to go to stat, over to calc, and pick my one var stats. Remember, list is whatever list I put my data in, and I put mine in L1. Frequency list should still be blank, and now we're going to tell it to calculate. So you notice X bar is the very first thing. The second and third entries on this output list we can ignore. SX, that's our sample standard deviation. So we always want to use SX unless the problem tells us that it's a population, or sometimes there will not be an SX. The calculator will leave that blank, and then we use the population standard deviation. But here, the problem says specifically that we have sample data. So that means that we want SX. Remember, the calculator calls it SX, but we just write S. So this is 13.05 for our standard deviation. Now, if we scroll down, remember this little arrow right here next to the N means we can arrow down for more information. So you see we have a min X, which is 24. So I'm just going to write this over here on the side. Min X is 24. Max X is 59. So again, if we do our range, it's 59 minus 24, which is 35. Okay, now we could either take 13.05, which is our standard deviation, and square it, Or once we've done the one var stats, we have a different option. We can hit the vars key. We can pick number 5, which says statistics, and hit enter. And then under this XY menu, you see number 3 is SX. So if we scroll down to number 3 and hit enter, it's taking what it calculated for SX when we did one var stats. And if we hit the little x squared key, it will square that and give us 170.3. Recall the other way to do that is just to write down our standard deviation, which was 13.05, then type it back in the calculator and hit the squared button and hit enter. And you see they're slightly different. And the reason that the two answers are slightly different is because 13.05 is a rounded standard deviation. So in the second calculation, we'd already rounded once, and in the first, we did not. But you notice they both come out to be 170.3 when we round. So that's it for this video. I will show you how to find those things in StatCrunch in the next video, and then we'll go on to the empirical rule.